Hey, Jordan.
What's up?
Not much. All right, so we've got Emily to join still. I know that Emily Mongold forgot her computer today, so she won't be joining. So we just need Emily Carr. I'm just going to remind her that I just sent the link. And while we are waiting, let's go ahead and get started. I know that it's been a while since we've had class in person, and so I haven't checked the in-class homework yet because of that, but I am going to be checking that when we're in person on Thursday.
Mm-hmm.
So don't forget to bring that on Thursday.
That's the homework. That's taking the notes and stuff for the videos, right?
Yes, actually, you specifically have quite a few things that I'll be checking. Like
Yep, I have them all lined up in my book.
Good. That's perfect. Actually, so did you finish watching all of the ones from Chapter 2 for me?
No, I haven't watched all the ones from Chapter 2 yet, but I have done all the stuff from Chapter 11. I did watch Chapter 2, the first part of Chapter 2.3, but I haven't been able to go back yet.
Okay, so you'll finish that up before Thursday?
Yes.
Good. All right, so I'll check that on Thursday, and that's perfect. Did you take detailed notes on 11.3 and 11.4 especially?
Yes.
Good. So you got those steps ready?
Yes.
Good. That's what we're going to be going through, especially the longest problems that we'll see on this test. With this test, I think, is all math.
Oh, yay.
Pretty sure that it's all math. Give me a second to check. Test over Chapter 10. We're in Chapter 10, right? Yes. All math. Yep. All right. Hello. How are you?
What?
How are you?
Pretty good. I didn't really understand the homework very well, but I did it.
Okay. So you watched both of your videos then? Okay. On Thursday, we are meeting in person, so I will see you guys Thursday. But today what we're going to do is try to cover sections 11.3 and 11.4 and just practice a bunch of problems, okay? Emily Mongold forgot her computer today, so it's just the three of us. So we're going to get started, okay? All right. Let's start in your book on page 383. We're not going to beat around the bush. We're just going to jump straight in.
Okay.
So page 383.
I still have my test here. I never returned it into you. I don't think I've had a chance to yet.
Yeah, we haven't met in person in a while, so I do need that because I would like to get that graded and put in the grade book. So please bring that Thursday. So guys, make sure you bring your test then. All right, so we're going to start with number 23. Do you guys all have your book in front of you and you can see that one?
Mm-hmm.
All right. It says the reaction between solid sodium and iron 3 oxide is one in a series of reactions that inflates an automobile airbag. Then they give you the equation for that. And if 100 grams of sodium and 100 grams of iron 2 oxide are used in this reaction, determine the following. So they're going to ask you, most of the time, they're going to ask you these same 4 questions. They may not always ask it in the same order, but these are most often the questions you're going to be asked. What is the limiting reactant? A. What is the excess reactant? B. What is the mass of the solid iron produced? C. Then what's the mass of the excess left over? All right, so those are the 4 most often questions that you're going to be asked, and you won't always be asked all 4 for every question, but those are the ones that you usually are asked.
Page 3 what?
383. And so we're going to get started with trying to find the limiting versus the excess, okay? If you remember yesterday, or well, whenever you watched the video, I gave you some steps. So what are those steps? Tell me, how do I find my limiting reactant? Emily, maybe this is why you struggled with the videos. Did you write them down?
It wasn't very clear how to write it down to me.
I will go back and rewatch, but I'm pretty sure I gave you like step by step on the PowerPoint. Here are your steps.
I'm not very good at that.
11.3.
What?
11.3?
Yeah.
Or 11.4. Okay, 11.3.
11.3. Jordan.
Yep, I got the steps written down.
Hang on. Emily, I'm calling your bluff. It was clear. I think I had them on a PowerPoint, like written out. 1, 2, 3. Do this to find the limiting reactant. Then I had other steps. I had them all typed out. You need to pay more attention to your videos. Okay? All right, so Jordan, help me out. What's step 1?
Okay, actually I don't know, just kidding, I have it.
I was about to flip a lid. All right, go ahead.
I have it right here. I got it.
Step 1.
Okay, so step 1 is to convert, determining limiting reactant.
Yep.
All right, just want to make sure. Convert moles of reactants to grams. Number 2, divide the moles of the reactants by the smallest mole. And number 3, compare the ratio of moles of reactants to the ratio from the balanced chemical reaction. And by the way, to Emily, yeah, she has it on there. I wrote, those are word for word what she wrote on the slides.
Okay.
Yay! So it's right there. Anyways, I am going to say the one thing. Jordan, fix this in your notes. Step 1 is turn grams to moles, not turn moles to grams, which you said. I don't know if you said it backwards or if you wrote it backwards, but
I must have wrote it backwards. See, there's got to be a pencil around here somewhere.
Turn grams into moles. And by the way, you did really well on that, so good job, Jordan. Step 2 was to divide moles by lowest to get mole ratio. By the way, we did that, I think, last chapter. Didn't we work with ones where we were dividing by the lowest mole to find the mole ratio? We were using that to find our subscripts. Yeah, it's very similar to the process we've already done when we found our subscripts for our empirical and our molecular formula. This is like exactly the same. Except for here. This is the only new thing, and this is going to be where we compare. Hang on, I had the capital lock on. All right, there. Compare mole ratio to the mole ratio in the balanced chemical equation. So the only thing I'm going to say that I'm going to tweak a little bit, I know I said multiply the moles and to find the moles of the product. I think that's a step that I think my book has this written down wrong. Sorry about that. So the next thing we'll do is compare it to the ratio in the balanced chemical equation. I'd like to spend quite a bit of time showing you ways to compare the mole ratio, because step 3 is the one step where people sometimes struggle. So I would like to spend a lot of time doing that and giving you, even without having all of the other steps involved, I'd like to spend some time giving you just practice problems here where I'll go, well, when you're done converting grams to moles and dividing by the lowest, this is your mole ratio. What do you do now? Okay, so I'm going to give you several of those. First, though, we're going to start with a real, we're going to go through all of the steps, the entire thing, and the first thing we're going to do is find the limiting reactant, which will also tell us our excess. So we start by turning our grams into moles. How many grams did they give us in this problem?
100.
They gave us 100 grams. Good. So they gave us 100 grams of sodium and 100 grams of iron oxide. So now, how do I turn grams into moles? What's going to go on the bottom?
Mole.
I'm turning grams into moles.
Oh, wait. Grams? Never mind. Grams will be on the bottom. Sorry,
Yeah.
Mr. You.
Okay, so what I need to do is find my molar mass. Notice, go ahead and see this. Grams. Grams will be on the bottom to 1 mole. So we need to find the molar mass of sodium and then of iron oxide. So we're going to use our periodic tables. Sodium is 22.99. And iron oxide,
That's FeO, right?
Fe2O3.
Fe2O3.
They actually gave that one to you in your problem. You didn't have to guess it.
Okay.
Yeah. So notice that I have in parentheses I have the 55.58 or 85, which is the molar mass of iron times 2 because there's 2 of them. And then I added that to 16 times 3 because I have 3 oxygens. So that molar mass is 159.7. Now look, I am rushing through this part because this is not new. This should be easy, right?
Mm-hmm.
All right, so that's why I'm going fast, and I will make you do this all on your own. I'm not going to give you all of the molar masses, okay? But for right now, I'm trying to save us some time so we can spend time on the harder stuff, which is the new stuff. So what I want you to do is divide those, and you're going to write down what the moles are. So 100 divided by 22.99 gives me
4.35, 3491768.
Good. Now, write out, like you don't have to write out the entire number, but remember, you're going to keep
I just
the whole
wrote
number
4.35 on the paper. Just to
on the paper is fine. But then use the whole number. Use the whole number when you do this. All right, so Emily, if you don't have, yes, Jordan, you're good. Emily, if you don't have a scientific calculator or something that will keep this answer for you where you can see it, you will have to write it all out, okay? So just make sure that you're using the entire number the whole time. Got it? All right, so now we're going to do 100 divided by 159.7. And that's going to be 0.626170, blah, blah, blah. All right, so here we go. We divide by the smallest. Which one is the smallest?
0.626.
Yes, so dividing that one by itself will give us 1.
And then dividing it by 4. So that would be 4 point, and this is where you use the whole numbers.
Yes, this is where you use the whole number.
Hold up, 717,268 divided by 0.626, 1704.
40.
Yeah, that's right. Oh, no, I don't. Misread it. Wait, no, I didn't. Never mind.
It's okay. It's going to give us 6.9. What are we able to do with that?
Round it up to 7.
Round it up to 7. Okay, so we're going to treat that like 7.
So that would mean for sodium, you would just have Na. You wouldn't have any number. And then for iron 2 oxide, you would have a 7 in front. 7 Fe2O3.
You flip-flop those. Look.
Oh, 7 Na. I'm sorry.
This is for the sodium.
Okay.
This is for the iron oxide.
Okay.
So be careful. So now, here's where sometimes, and Emily, I really want to hear you because I know you turned your mic off, but I want to hear you answer on this one so that I know that you're tracking with me. This is the new part. Step 1 and 2, not too bad, right? Step 3 is right here. we are going to make what I like to call a truth table to compare the mole ratio that we just got with the mole ratio from the coefficients. All right. So I always set up, and look, I do this way so that I have this space on my paper right here. Right here is where I'm going to make my table. So I'm going to write down the two elements that I have. I have sodium for one, and then I have iron oxide for my second chemical. All right, so I have these two, and I've made a table so I can compare. See? Now look.
Would you have Roman numeral 2 or like the number 2 for Fe2O2?
Look in your book. It's actually right there for you.
Never mind. Mine drew a blank.
All right, now look. We're gonna be putting the coefficients on top. Listen, this is very important. You do not change the coefficients. They are the standard that you are comparing the mole ratio to. So these must be from the balanced chemical equation, and they do not change. So you need to look right now and tell me, in the problem they gave you a balanced chemical equation. What is the coefficient for sodium?
6.
Hang on, let me try something. Aaron, your mic is muted. Can you unmute it for me?
But the sound doesn't work now.
There we go, we're better. All right, so sodium has a 6 as its coefficient, okay? So we're putting that from the balanced chemical equation, okay? Now we're going to compare iron oxide. What is iron oxide's coefficient?
It doesn't have one on the beginning.
If it doesn't have one, we understand it to be
1.
1. So notice, look, these are from the coefficients. You always do these first in your truth table because they cannot change. This is the standard. Our mole ratio will either be more or less than what we need in the standard. Got it? Okay, so now we write down the numbers that we just got when we converted grams to moles. Got it? So we're going to say for sodium, we had how many for our mole ratio?
6.
Mole ratio, not the coefficients. So look at what we did when we converted in steps 1 and 2.
7.
What was the number that we got for sodium in steps 1 and 2?
4.349.
Yep, but then we divided that by 0.62 to get the mole ratio. These numbers right here, the 1 and the 7, those are my mole ratio. Okay? That's what I got, the 7 and the 1. See? Remember when you divided by the lowest?
Yes.
So sodium has what number?
It has 7, which means the excess.
Yes.
It has 7 as an excess.
Yep. And then iron oxide was 1. All right, so now look. Here's what you need to compare them. One of the sides must be the same. And then you compare the other side. Here are the choices that you're going to see when you compare the other side. The other side will either be more than you need or less than you need. If it's more than you need, that means that that thing is the excess reactant. If it's less than you need, that means that that thing is the limiting reactant. Okay, so let's check our table. Is at least one of these between the iron oxide, you look at itself, or the sodium, is at least one of them the same?
Yes.
Yeah.
Which one is the same?
Iron.
Iron. So look, because this is the same, we are able to compare this one. You're not comparing it this way because it always will be. That's not how you compare it. You compare it with itself. The equation said you needed 6 moles. You really have 7 moles.
So
Is
you
that
have 1
more or
excess.
less than you needed?
More.
That's more.
That's more than you needed, which means sodium is my excess reactant because it's the one that has more than I need.
Oh. I did not get that during the lesson. Now I get
This
it.
is a
Okay.
big part of the homework I have time with.
Yeah, it's just really hard to teach it on when you're not actually getting the feedback from the kids. It's hard. I think I need to re-record that video anyways because I don't think I did this part as well.
That part was a little confusing when it asked the question, which was the excess. I was like,
Yeah.
That one?
Yeah, so that's how we tell, all right? And I'm going to give you a couple truth tables so that you guys really get good at practicing this, okay? All right, so right now, we're going to finish this problem, and then we'll come back and practice more truth tables.
Oh, it's
all
not
right?
finished?
What?
Not finished?
No, that's just the beginning. Look, A, B, C, D. This is a 4-part problem. These are
Oh
going
my
to be
goodness, I thought we had at least got to the halfway point.
Look, because they are so long, they're worth a lot of points. This is going to be worth like 30 to 40 points on your test.
I wish you
It's
hadn't
on these
told me that.
problems.
You
It's
hadn't told me
really
that.
important that you know how to do these, guys. Really important. It's almost a third of your test, or a fourth, or yeah, almost
Okay,
closer to a third.
Stop. I'm going to get flustered on the test, and then I'm not going to remember any of the steps. So please don't. Just tell me that it's really important for me to memorize them.
It's just really important for you to memorize them.
All right, stop right there. Got it.
I'm done. It's just really important, that's all. Okay, so A. Do you notice how we now have the answer for A? Which one is the limiting reactant?
Ion.
Good. Which one is the excess reactant?
Sodium.
Good. So notice how we just answered A and B. Right? Now what's C ask? What is C asking you?
How much ion was produced?
How much iron is produced? Notice, look, this is a product. It's not one of the original things that they gave us, right?
Yeah.
Now look, this is the nice thing about this. C and D are usually just simple stoichiometry. You start with one thing, you're converting it to another thing. But here's what you need to know. The reason we find the limiting reactant is so we know which one of these to choose from. All right? So we have to start with the one that's going to run out first and stop the reaction. Which one is that?
Iron trioxide.
Good. The iron oxide is going to run out first. So look, when we do C, start with the grams of iron oxide of the limiting reactant. So you're starting with the limiting reactant. And you're simply setting up a conversion from grams of one thing into grams of what they ask for. And what do they ask for?
Fe.
Determine the solid iron produced.
So grams of just Fe. Look, this should become a really easy problem. This is gram to gram conversion. So how many steps are we going to take?
4. Well, 3.
There's 3 tables. Yep. So go ahead and set that up for me, okay? Hey, by the way, you already know the molar mass because you found it. So iron oxide is really going to have 159.7. So that's an easy step, isn't it?
Mm-hmm. So it'd be 100 divided by 159.7 again.
Yes. So that's 0.626. That whole long number, you're going to use that number again.
So we're converting from iron oxide to ion plus from grams to moles.
Well, it's a gram to gram conversion, Emily. They start you started with grams of iron oxide and you're converting into grams of just iron. So after we set up this part, look, this is our grams of iron oxide into moles of iron oxide. What is the next conversion?
So you would have 2 moles of iron oxide on the bottom. Iron on the bottom.
Which one needs to cancel?
Oxygen. So you have 3 moles of oxygen on the bottom.
What do we have here?
Iron oxide.
What has to go down here to cancel?
Iron oxide.
Iron oxide, so it'll cancel. So you remember, if it's in the top, you immediately put it on the bottom. And Jordan, what you're doing is you're going to convert it into iron. So the 2 moles of iron that you were talking about, they go on the top, not on the bottom.
Okay.
All right, so look, we had, hang on, let me find we had 1 mole of iron oxide to 2 moles of the iron. Now that I have, look, see how this happened? I had grams of iron oxide and it canceled and turned into moles, right? Then I turned moles of iron oxide into moles of iron on its own. This is my mole ratio. Now that I have moles of iron, how do I turn moles of iron into grams of iron? What has to go down here to cancel?
Grams of no, mole.
Mole, good. And what goes up here?
The grams of iron.
The grams of iron, good. So we put 1 mole of iron on the bottom and the grams of iron on the top. The mass of iron on its own is 55.85. 55.85. But do you notice how this is just, like, we already learned this. This is what this chapter is testing, right? That you know how to do stoichiometry and convert from one thing to another. This is it, right?
It would be 70 grams of iron.
The only thing I'm going to say is you didn't have the right number of significant figures. How many do you have with 100?
3. So it'd be 69.9.
Not 3. Let me type it in. 100.0. It's very specific when they typed it because they actually included a decimal place and another 0. Do you see that? They said 100.0. So when you have a decimal, the first non-zero is the 1. Everything, the 1 and everything after is significant. So there's 1, 2, 3, 4.
It would be 69.94 grams of iron.
They have 69.92, but that's probably because the molar mass is just a hair off.
Mm.
Because we're using 2 decimals, they probably use more. So I'm going to take that, and that'll be fine. Okay?
Okay.
Now, that was simple stoichiometry. The only thing you guys the only thing that's new about that is you have to start with the mass of the limiting reactant, which is why you found the limiting reactant in the first place. Got it?
Yes.
All right. So now D is, again, going to be a very simple problem. D is asking for how much is left over of the excess reactant. Okay? So what you have to do is find out how much did you really use. All right? And then when you figure out what you really used, you can take what you started with and subtract what you used, and you'll get the leftover. So this is, again, the first thing we're going to do here is just a normal stoichiometry problem. So we start with what?
Excess.
No, we're looking for the excess. That's what we're going to convert to, is sodium.
You look for the limiting.
Start with the limiting. Look, in C and D, both of these problems are exactly the same. You start with the limiting, okay? So we're going to pretty much have very similar setup to our table. We're going to have 100 grams of the iron oxide, and we're going to convert that the same way, grams into moles. And then we convert, instead of converting into iron, this time we're converting into our excess reactant. Which one was my excess?
Sodium.
Mm-hmm. So we're going to put the moles, which was 6 moles of sodium on top. And then we convert moles of sodium into grams of sodium. So what's going to go on the bottom to cancel?
In the periodic table, the mass of sodium.
Is that going to need to be on the bottom?
It's going to be on top. On the bottom, you'd have 1 mole.
That's it. Good.
And it would be 22.99 on top.
Yes. All right, so look. Check yourselves. Emily, check yourself. This is what your table looks like in the end.
Yep.
Okay.
Got it? Did you do it right with this converting?
I think so.
Okay. All right, now multiply and divide, okay? So we're going to go 100 times 6 times 22.99 divided by 159.7 divided by 1, which is the same thing. So we're going to end up with, look, so here, notice when you do your multiplication and your division, you end up with 86.374451, right?
86 point what?
You see it?
521. Okay.
Yeah. Now, how many sig figs are we going to have with that?
4.
So we have 86.37, right? Now, here's what you need to do next. This is how much of the sodium was actually used. How do I figure out how much is left over if I have the starting amount and the amount that I used? What do I do with those two numbers? All right, look. How do I find out what's left over? I have what I started with, and I have what was used. How do I find what's left over at the end?
Subtract.
We just subtract them. All right, so we take how much iron, or how much sodium did we really, how much did we start with in the original problem? What? I think I heard you say 100. That's right, 100 is right. So we take 100 minus 86.37.
14 or 13.63.
Good, so 13.63. Now look, significant figures when you're adding and subtracting are different than when you are multiplying and dividing, right? So you had 4 sig figs here because we were multiplying and dividing. When you subtract, you go with the lowest decimal place. So which one, how many decimals am I allowed to keep? 1 or 2?
1.
I'm only allowed to keep 1 decimal place. So I'm going to round this number to 13.6. 13.6. That's how much is left over. Joel is awake randomly. That's really bad because we still have like 24 minutes left. Here's what I need you guys to do while I go get Joel. Start working on problem 24. All right, so start working on that one. It's the same. I will give you the equation. So let me just type that in because I actually want you to practice just doing the work, not just working on the equation for me. So I'm coming, Joel. He's like calling for me. There. All right, so here's your balanced chemical equation. 6CO2 plus 6H2O yields C6H12O6 plus 6O2. Write that down and start working on problem 24.
Hey, Joel.
Hi. Mwah. Yeah, I'm awake early. That's fine. Yes, sure, you can play with my calculator. Okay, guys.
It's already broken.
It's not already broken. All right. What are you guys, how are you doing with steps 1 through 3 to do A and B?
What do you mean?
Come on, guys. What did they give you?
Okay, so 6 CO2 plus 6 H2O produces C6H12O6 plus 6 O2.
Yeah.
And then you're to find after writing the balance equation, thank you, is determine the limiting reactant.
Okay, good. So you need to find the limiting reactant. So how do you find the limiting reactant and the excess reactant?
This is where you draw that truth table, right?
On step 3, yeah. What do you do first?
Um,
Come on, guys. We just did this. Look at your steps. They're on the page still. They're in the chat group.
5 moles by low. Oh. You will find the lowest mole ratio between carbon, oxygen, and hydrogen.
Step 1. Turn grams into moles. What did they give you for your two things? What was the problem? What did it give you?
6 CO2 plus H2O.
No, look at the actual whole problem, not the equation. Look at the problem and see what they gave you for the masses.
C6H12O6.
Keep reading. A plant
Oh, 88. I completely missed that. 88 grams of carbon dioxide and 64 grams of water.
That's our starting point. So you have to do what with those grams?
You would multiply the carbon by the 88.0 grams of carbon dioxide and divide it by 1 mole of carbon dioxide.
We're converting grams to moles. So what has to go on the bottom?
The grams would go on the bottom. The moles would go on top.
So are you multiplying or dividing?
Dividing.
Yes. So you would divide. I see. You're turning on the printer, huh? Right now.
Whoa, what's that? All I heard was like.
He pushed buttons on the printer and turned it on.
Discovery.
It's off for a reason. It's broken. So it made that funny noise and it scared him.
I saw it. He like jumped up and was like, oh.
It's okay. All right, you get back to work. It's okay. It's okay. I know. I know. Evil printer. You shouldn't push buttons, huh? It's broken because he pushed the buttons on it. Yes, it's all your fault. It's all your fault that it scares you now. It's okay. It's okay. That's okay. Yeah, so now we're gonna push buttons on Mommy's calculator and break that too. That's just great. Have a piece.
At least the calculator doesn't make funny noises.
True. All right, so how many moles do you have of each of these? You should be that far at least. Let me see your work. Emily, we'll start with you. Hold it up.
I can't really see it myself.
All right, good. So hold it. Keep it still, right there. 44.1, 64, 18, 102. Good. So then scoot it over to the left for me. So you divided. Okay, so you're at this step. What do you do now with those two?
I divide them both by the smallest, which is 1.99, so on and so forth.
Good. So divide them both by the smallest. Good.
I think this is where I'm confused at. What is it I put up top? What is it I'm dividing? I mean, I know I divide by the 88.0 grams, but I'm not sure what to put on top.
All right. Jordan, this is a simple, the first step is a simple gram to mole conversion. So you put 1 mole on the top.
Yes.
So you're going to start with, hang on, let me write it down, 88.0 grams. Let's not play with mommy's water. You can take a sip, but we're not going to play with it. 88.0 grams of carbon dioxide, CO2. And the molar mass of that is 44.01 or
That's
02?
what I have in my calculator.
01, okay.
Okay, now I get it.
1 mole on the top. So Jordan, look, this is how it, you see that?
Okay, that's why I got a different answer. I had it in reverse.
Yeah, so then the next thing you have is 64.0 grams H2O. Water is 18.02 grams for 1 mole. I got a very clingy baby because he's tired. Great. All right. So now when I type these in, we're gonna have 88 divided by 44.01. Stop turning it on. It's just shiny buttons, Mommy. How could I resist? All right, so I have 1.99954, blah, blah, blah. I told you. I told you. I know.
That was the printer?
Yes, that's the printer.
That sounds like a buzzsaw.
Yeah, it's very messed up. All right, so now when I divide both of them by 1.999545558. All right, so you divided them both by the smallest number.
Yes, and the smallest one is 1.99, blah, blah, blah.
Good. So this one, the top one is 1, and the bottom one's going to be 1.77.
Yeah.
And look, we don't really care that it's 1.77.
We don't have to make it a whole number.
Hang on. Let me do this. I'm going to FaceTime his dad and ask him to...
You can FaceTime on my mom again. We can try that.
Well, I know that his dad is done working, so he will... Hang on! Shh. Hey. You're fine. Okay, so look. It doesn't matter that it's not a whole number. Unlike the other one where we had to have a whole number, we do not have to have whole numbers here. We just have to compare them to the coefficients. So now you have to set up your truth table. So write CO2. Hello. Guess who woke up early? Hang on. What? No, I didn't hang up on you. I'm FaceTiming you.
Well, my phone's in my back pocket.
Oh, well, that's why the screen's all black. Anyways, I was just going to hope that you could FaceTime Joel for a minute so that he'll sit on the couch and be happy. Because I can't teach with him in my lap. It's kind of being rough.
Yeah, hang on.
All right, I'm going to get him sitting. Thanks. Come here. Look, it's Dad. Look. Grab it. Come on.
Can he see me?
He can. Normally that would be enough, but he's being kind of sad right now. Come here, look.
I can't see him.
All right. Well, I'll see you in a little bit. Love you.
Yeah, bye.
Bye. All right, that didn't work. He's not happy. All right, so here we go. CO2 and H2O. Ta-da. Remember what goes on the top? The what?
What they gave you to start with.
The yes. In the balanced chemical equation, you put the what?
For this one, you would put 6 in CO2.
Yes, you're putting the coefficients. So we have 6 for CO2 and we have 6 for H2O, right?
Right.
Because those are our coefficients. Now look, here's the only catch. It doesn't matter if it's a whole number or not, but it has to have at least one of them be the same. So we have 1 and 1.77.
Oh, neither of them.
Neither of those are 6, but what could we do to make one of them be 6?
Multiply.
Multiply. If I multiply 1, I have to multiply
The other.
the other. So I'm going to multiply them both by 6 and compare it to the coefficients, okay? So 1 times 6 is obviously 6. 1.77 times 6 is
10.62.
10.62. So now do you see how you can compare? Because at least one of them is the same. You can now compare the other.
So H2O is your excess. CO2 is your limit.
That's right. That's the answer to A and B.
Okay.
All right, does that make sense, guys?
Yeah. A and B are usually fairly easy. C and D, well, in this case, D is the difficult one, and E.
All right, so now that you're going to start on C and D, well, actually D and E. So now that you're doing D and E, which one of these are we going to start with? Are we going to use H2O or CO2 to start each of these problems?
You're going to start with H2O because it's saying the mass in excess.
You're starting
Hang on.
with 2.
Now these are reversed, so that's fine. So D is really finding the mass in the excess that's left over. So remember, what do we have to start with?
What you had in all. You would be adding the two together.
This is just like D in the last problem. We are looking for the excess left over. We always look at this point. Look, write it down. Once you get done finding the limiting and the excess reacting, the other two problems are going to be stoichiometry. And when you start your stoichiometry problem, you always start with the mass of the limiting reactant. And then you convert it into whatever they've asked for. Write it down. You always, let me write it down here. Always start with the mass of the limiting reactant, then convert to what they asked for. Make sense? So
Yep.
What is the limiting reactant again? CO2 or H2O?
CO2.
CO2. What mass did we start with of CO2?
I've been trying to answer all this time. Emily, it's your turn.
What?
What mass of CO2 did we start with?
88 grams.
88.0. So look, you're starting there and converting that into, in this case, the mass of what? What's my excess reactant?
H2O.
Good, so I'm going to convert until I get grams of water. See? I set this problem up, start with the limiting, and I'm going to end with the excess. So do your 3 conversions and get from the limiting to the excess. Sleepy baby. How about I get him a snack? You guys go ahead and do this problem, and then afterwards, if you finish, go on to the E, all right, and solve that one as well. But I'm going to get him a snack and sit him down. See if he'll eat something.
So they want us to find the excess of H2.
She wants us to convert the carbon dioxide into water.
You're trying to
Okay,
find
that's
the
what I
mass
thought.
of water left over.
Right, okay.
Left over when you're done.
This is so stressful to me. I don't know why. It's really hard. Okay.
All right, he is happy because he has fruit snacks. All right, guys, so what did you get when you converted into grams of water?
I'm almost there. I'm on the third step.
Okay.
I'm not sure I'm doing it right.
I might be wrong, but I got 10.16 grams of H2O.
Made?
Yeah.
Yeah.
I think I did it wrong.
You're wrong. Let me see your work.
Sort of scattered. So I'm like looking up and down, just trying to write it everywhere. Anywhere where there's space. I'm probably gonna start a new page.
It's good. I need to see lower on the page, Jordan. Lower on the page. All right, so let's see. That's where I see you start. Hold it there. Got your. Hey guys, right now.
Lucas,
Sit for a second. Oh, yes. Sit and eat.
take you to the couch and sit down. Okay?
Yeah,
It's
don't.
my mother.
Yes, that's fine. Just.
I was going to tell James best regards from my mom. They have the whole thing.
Oh, this is gonna be fun.
Okay,
All right, Ryan,
you want
Luca.
that?
You didn't obey. Go sit down.
So you have to sit on the couch if you want to keep the icing. If you get up again, she can take it and put it in the freezer. Okay?
Okay.
And by freezer, I mean the one that starts with the letter T.
Yeah. See ya. Okay, Jordan. So I see the first step. You converted, and that's fine. Now hold it up higher so I can see the next step. So you should have taken the. All right, actually, I don't see the next step. Look, I only see the part where we did.
It's on this page, but it's not organized. I was going around looking for space.
All right. Look.
Starting over again on the next page.
Keep them grouped close together for me because otherwise I'm not going to be able to follow your work. And we do have, I'm going to stay on a little longer for this video because I feel like with having.
Well, what answer did you get, Jordan?
Our house.
Mine was 10.14, but that was wrong.
And were you trying to convert CO2
What?
to H2O?
There are no warnings with this.
Yeah.
You can sit now without your slushie. All right. I have no idea what I was saying. Emily,
What?
let me see your problem really quick. What did you end up having, Emily? And Jordan, I need you to rewrite that problem so I can actually find it because
I know it's wrong. I have about 1,297 times of H2O.
no. Hold it up so I can see what you did. Give me a second.
I kind of have an idea of what I might have done wrong, but I don't know.
All right, Emily, hold it up. Let me see. All right, hang on. You got to give it a second. Keep it steady. Let it get in focus. So I see 88.0 grams of CO2, and I see the 44. That's your problem, Emily. When you convert grams to moles, how many moles do you have?
Moles of CO2.
Yeah, look, the very first step you did, grams to moles. This is like last chapter. How many moles when we convert grams to moles? It is not 6.
But that was the subsequent.
No.
That was the coefficient.
No, you don't use the coefficient there. You only use the coefficients in the new conversion, which was the mole ratio. You don't use the coefficient when you're doing a gram to mole conversion. You only use one mole. Remember that? That was like last chapter we said that whenever we converted from grams to moles or moles to Avogadro's number, we always had how many moles?
1.
It's always 1. Look, it's just like it's wrong to say that there are 12 feet in 1 inch. It's 1 foot for 12 inches. It's 1 mole for 44.0 grams of CO2. It is always 1 when you go in gram to mole or mole to gram. It's not until the second step where you change moles of CO2 into moles of H2O that you use the coefficients. The only place you use the coefficients with moles is in the mole ratio. And in that sense, in that step, you have moles on top and bottom. Do you see that? So Emily, all you have to do is cross that first 6 and cross it out and put a 1. And then where you have the next step when you're doing moles to moles, so you should have how many moles of CO2?
1.
You put 2, and that's wrong.
What?
Hold your problem.
You just said 1.
I'm talking about the next step now. We're now on to the mole ratio. And the second step, so it's literally the third column over. Look there now. You notice how you had CO2 on the bottom and you had H2O on the top?
Yeah.
You had 2 and then 6, right? Or 2 and then something. I didn't pay attention to the second number, but the 2 on the bottom, that's wrong. It is not that. That's the mole. That is where the mole ratio goes. Luca, Ryan.
I don't know what you're talking about because I didn't have a 2 anywhere. My camera is really bad.
All right, hold it back up then. Maybe I misread it. I thought you had a 2 there.
Yeah, my camera's terrible. I could ask Mike to change
Oh, is it a 1-to-1? Is that what you wrote? Scoot it to the left now.
At first, I had 6 on top for both of them, and then 1 on the bottom for both of them. But then I turned them all to 1 when he told me to.
Okay, it's what we're looking at is the part where it says moles of CO2 to moles of H2O. Look at that right now. I think you have 1s written there now.
Yeah, because you told me to have 1.
No, I did not tell you to put 1s everywhere. I said where you put grams to moles, that's where you need 1.
Okay.
And I've told you very specifically that where the mole ratio is, that's where the coefficients go. You see how you're converting moles of CO2 to moles of H2O in the middle? Moles on top of moles. Do you see that spot?
I'm not sure.
Look, it's right here. We are talking about this spot right here.
Okay.
This is where your coefficients go. It's the mole ratio. This is where you need 6s.
Okay.
Not on the first one because that's gram to mole. Not on the fourth one because that is gram to mole as well. Anywhere that you're converting grams to moles, it was always 1 mole. Always. Anywhere where you're converting grams to moles, you have 1 mole. Because look, the reason, listen, this is so important. It's grams per mole. That's what we find when we find our molar mass on the periodic table. And we spend an entire chapter going over this. It's not new. It's old. This should be something you already have memorized. Grams to moles is literally written as gram per mole. When we look up the molar mass of like water and we say 18.02, we say grams per mole. What that means is that there's 18.02 grams over 1 mole. Stop fiddling with your pen and like look at me through the computer because I don't feel like you're listening. Because I say this to you often and you don't, it's like it's not clicking. It's grams per mole, which is why there's 1 mole. Let me ask you this. If you were to get in a car and get driving down somewhere, and you are driving 25 miles per hour, how long will it take you to go 25 miles?
I'm guessing an hour.
Listen, what? How many hours? Why? Because it's miles per hour. 1 hour, 22 miles, or 25 miles, right? It's per. Miles per hour. This many miles over 1 hour. Same thing here. Grams per mole. However many grams per 1 mole, always. Which is why when we convert grams to moles, it's always 1 mole. But the middle part was the new thing that we learned this chapter that you are having to memorize. The new conversion with moles is new. We said that the old one where we go grams to moles or moles to particles, that's still 1 mole. But the new step where we convert from one thing to another, that's where you use the coefficients and only there. Does that make sense?
Yeah.
We've been practicing it every time we do math this time. It has literally been something we've practiced every lesson that I've taught since we started this. This chapter, every time you've done stoichiometry, you've had to do that. It's not new. It shouldn't be confusing.
Okay.
Emily, do the math over now that you have the right numbers. Let's see what you get. Jordan, hold your paper up, please.
First step is up
All right,
top.
step. That's perfect. And it's actually in focus, so hang on. 88 grams, 44.01 1 mole. That's great. Then you start with 1.99. You have 6. And here's your problem. Let me check their other part first, though.
Oops, sorry.
And 1 mole to 18. All right, so look at the where you did the 1.99 and you have 6 moles on the bottom.
Yes.
You are converting that into moles of what?
H2O. So I should have the 1 mole on bottom, the 6 on top.
You're basing them both on their coefficients. What are both of their coefficients?
Oh, it's CO2. So it would be 2 on the bottom. Wait, 2 on top, 1 on the bottom. My bad.
Stop trying to guess. Look. Look at me. Just slow down and think. It's moles of CO2 on the bottom. You didn't label it, and that's why you're struggling. You only put mole, you need to label it. Write it down right now. CO2. What did you turn it into on the top? Moles of what?
Carbon.
No. That's why you don't even know. It's
Oh,
moles.
it's supposed to be moles of H2O.
Yes. Write that down. Now, you based the moles of carbon, CO2, you based that on the coefficient, but you didn't do that for the H2O. What is the coefficient on the H2O?
6.
So what do you need on the top? Not a 1, but a
6.
6. That is what your mistake was. You need to have the coefficient for both of them, okay? And the reason you made that mistake, I think, is because you didn't label them, and so you probably were looking at the wrong thing. You might have looked at glucose for all I know, but you don't have 1 mole of it, you have 6. It's based on the coefficient. After you do that, you'll get the right answer because you have the second part set up very perfectly. All right? Luca, keep the straw in the cup. All right, Emily, what did you get when you finished and fixed your math?
36.0.
Yes, that is perfect. But look, this is how much we used. How do you find how much is left over? We used 36 grams. How much do we start with?
80. No. 64.
Yes. What do you do with those two numbers?
We subtract what we used from what they gave us.
Yes. So do that now and you'll find your final answer. It's okay, he can play with it. All right, Jordan, what did you get when you finished? Hang on. Yes. Now, Jordan, that is how much you actually used. How do you find what's left over? Because you can't leave that as just that answer.
You subtract it.
From what?
It says that it gives you 88.0 grams of carbon dioxide and 64.0 grams of water. You would subtract from the water.
Good. So go 64 minus 36. Ryan, you can
28.
28 grams is correct. How many, like when you write it, do you just write 28 or do you write something else?
I write 28 grams of H2O.
Okay, but look, sig figs. How many decimal places do you need?
28.0, sorry.
Yes, that 0.0 matters. Emily, did you get 28.0?
I guess I wasn't paying attention to that. Sean.
I'm sorry, I couldn't hear you. What?
I got 28, but I didn't remember putting it.
Okay. The reason you need the 0.0 is for your significant figures. You still have to have 1 decimal because there's a 1 decimal in both of these numbers, okay? So you need to have the 0 to hold the place value, okay? All right, now look, that's how much is left over. Now we have to do E, which is find the mass of glucose produced. All right, so what do you start with? Got visitors. What do we start with? Come on, guys. It's always the same. No, Jordan, you can answer this one too.
Oh, okay. This is for E.
Yeah. To find glucose, what do we start with?
We start with the whole, what you had in whole.
Do you start with your limiting or your excess reactant?
Limiting.
You start with your limiting. Start with the mass of your limiting and convert that, the same process, convert it into the mass of the glucose. Start that now. Emily.
What?
I'm going to phrase this right. You are looking like you are checking out and like you're frustrated. Can you please address that and fix it for me?
Oh.
Thank you.
I love to play with this days.
I'm going to have to teach them longer than I would normally because there was not a lot of progress made when he was awake. It was just really hard to actually teach them, so.
No. We're not done with it. We're not done with it.
I just want to play with this.
Know when you need me. Shoes on.
Yeah, because we're gonna play outside and with this.
The last one, it took me a moment, but it was like the last one was supposed to be the easy one. If I can get it down there. There it is. That was the answer I got for how the math.
Show me the beginning of your work, please. Because I can't.
That was all on my calculator.
James,
Yes.
can we play?
Because it said that it produced C6.
All right, look, that's just the molar mass.
I gotta convert it to grams.
No. Listen.
Look, are you done?
That is your molar mass. When you convert moles of C6H12O6 into grams of C6H12O6, you will use that number. But
Oh, okay, I remember
you
now.
need to start now with what? What are you starting, Ryan? Stop. What are you starting your conversion with?
88.0 grams of carbon dioxide.
88.0 grams of CO2. And then you have to go through all 3 steps, Jordan, to convert grams of carbon into moles of carbon, then moles of carbon, I'm sorry, not carbon,
Yes.
carbon dioxide into moles of C6H12O6, and then you need to convert grams into moles of the,
Go.
moles into grams. Can't even talk right now. Hang on. It's the same steps, okay? So just work on that. You're going to use that number later in that problem, though, okay? Emily, are you still working or are you finished?
Still working on it. Let's see. Is it 64.7?
Do me a favor, Emily. I gotta actually check through the steps to see. So go ahead and hold it up.
Yep.
Let me see.
I don't really have the intro written down now, actually. I just have it on my calculator.
Okay. Do you have the work written down?
Yeah.
All right.
What's
Stay
my
there.
camera?
Yep.
My
Stay
camera?
right there. Just stay there and let
My
me.
camera's really bad. I could write it like down more legibly.
Alright, so that's I think 88 grams of CO2, 42.
It's so wet.
60.
Do you want me to write it down better?
Just help me because I can't tell what you wrote for a couple things. Scoot it over for a second, too. See the last
we're
one,
going
1
outside.
mole, 184.12. All right. So
Yeah.
go ahead and put it down for a second, and let me just ask you verbally. Notice how you started in your table when you had 88.0 grams of CO2, right?
Uh-huh.
The first setup, on the bottom, I know that you had 44.01 grams of CO2, and above it, what did you have? How many moles of CO2 did you say? Was that 1?
Yes.
That is perfect. Okay, so that is supposed to be 1.
Okay.
Now
So
let's
it
go to
could
the
give
next
you
column.
1.9. Da, 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 da.
So on the bottom, you have, I think, a 6 moles of CO2, right?
Yes.
Good. And what did you have at the top? Did you have a 1 or a 2?
1.
Good. So that is supposed to be a 1. And then the next thing you had was 1 mole of C6H12O6, and on top you had
194.12.
194.12.
Yes, my molar mass.
All right, give me a second to check that molar mass because my answer is just a little bit different than your answer, and I think it's because of that molar mass, because everything else is set up perfectly. So I'm going to do 12.01 times 6 plus 12.0, 12.12 H plus 16 times 6. All right, so I have 180.18 for my molar mass. And so, Emily, I think that you just had the molar mass wrong. So go ahead and just write that in. I'll type it for you. The molar mass, the grams of C6H12O6 instead of the number that you had should be this number, 180.18. All right?
That's what you're multiplying it by, right? When you get to the final step.
That'll be on the top, Jordan, yes. So that'll be what you multiply in the end.
So 180.
Good. Now use that number and redo your multiplying and dividing, because I think that you'll get the right answer this time because you did all of the other setup right.
Okay.
I think it's the middle step that I keep getting confused on.
Now I have 60.
Yes.
Okay.
Yes. You have 60 grams. Good job. Jordan, did you end up with 60 grams?
No, I ended up something that was not even close to that. And I think it's right on the middle step that I keep getting thrown off.
All right. How many moles of CO2 do you have?
You have 6.
So that goes on the bottom. And then how many moles of C6H12O6 do you have?
1.
That goes on the top.
Okay, I had it backwards.
So yeah, you're going to use your 1.99955 for that number, and you're going to divide that number by 6.
Okay.
And look, Jordan, the reason you're switching them is probably because you're not labeling them. You have to label CO2 has to go on the bottom because it needs to cancel, okay? So I think that that's probably just your mistake, is that you're not labeling, because the last time I checked your work, you didn't label that step, and it's what made you mess up, okay?
Okay.
All right, so now look. This was all just the limiting and excess reactant. Do you guys have 10 minutes to do percent yield?
Yes.
Sure.
Okay, let's do a percent yield problem, because that is really easy. Actually, it's stupid easy. That's what I like. Okay, percent yield. Go to page
What did we do wrong?
386. Page 386.
Okay, now I got 60 just.
All right, good job, Jordan. All right, page 386.
386.
Yep, 386. Notice how they say percent yield is the actual over the theoretical times 100, right? Now look, the actual yield is what they will give you in a problem. They have to tell you an actual yield because they find it by doing an actual experiment, which is why it's called the actual yield. They found it in a real laboratory, okay? So this number is already given to you. You just have to find it and put it where it belongs, which is on the top, okay? And look, it goes alphabetical, actual over theoretical, because actual is alphabetical, okay? So theoretical yield. And guess what? This is the thing we've been doing the entire chapter when we do stoichiometry. It's just a stoichiometry problem. You take whatever they give you, you do a gram-to-gram conversion and turn it into what they ask for. That will give you your theoretical yield of the things they want, and then you just divide those two numbers and multiply by 100. Okay? It is literally that simple. Okay? Always give me 2 decimals. Let's start with the practice problem. Number 28. Aluminum hydroxide is often present in acids to neutralize stomach acid, which is HCl. The reaction occurs as follows, and they give you a balanced chemical equation. If 14 grams of AlOH3 is present in an antacid tablet, determine the theoretical yield of AlCl3 produced when the tablet reacts with HCl. So look.
You would automatically think that it's 100 grams in all.
You're jumping steps. We don't have to worry about that because they didn't give us, they're looking for a percent. They're not giving you a percent.
Okay.
They're asking for a theoretical yield, right? In this problem, did they give you an actual yield?
No.
No. Good. They're not actually asking for the percent yield yet. This one is kind of baby stepping you into it by just getting you to realize the new term, which is theoretical yield. So all you're going to need to do for this one is the stoichiometry. So you're going to start with 14.0 grams of AlOH3. And you were going to convert it into grams of what thing?
CL3.
That's it. See how you're doing a stoichiometry problem to convert from what they gave you into what they asked for, which is AlCl3. That will be the theoretical yield. So go ahead and do that. It's going to be a 3-step problem. Convert it from grams of the AlOH3 into grams of the AlCl3.
That's the 3 steps from the other problem.
Same exact, the same steps. Yep. Hi, Luca.
I'm fine.
Didn't she just...
So aluminum.
I'll help her when she's ready.
Guys have tasers and can stop it. Spin robots on us game now. I know, but it doesn't matter if they tase me. I can't shoot back. I can't tase them. It's impossible.
Why would you place
Go. Sorry, I'll do that next time. Okay, guys, I'm here. So, how far are you? Have you already converted this already?
I'm not going to do the second step right now. I think I'm right because you're supposed to add up AlOH3, and I got 78.01 grams, and that's what you would divide into 14.0 to get the moles.
Yeah. Yeah, that's right so far. And you're right about the molar mass being 78.01, so that's good. Keep going.
So now this is where the coefficients come in because it's moles to moles.
Yes, good,
So on bottom you would have the moles of AlOH3,
good.
and that's only 1 mole.
It's just 1 mole, good, because there's a 1 for your coefficient.
And then on top, it's 3.
Look at your coefficient.
Oh wait, it's AlCl that we're changing it to, not HCl. Sorry. It's 1 mole on top.
Good job. So it's actually 1 to 1.
So it's gonna stay the same. 0.17 moles of AlCl.
Yes, that is correct.
And now with the last problem, you would add up the grams of AlCl.
AlCl3. It's AlCl3. And you're right, it goes on top. And look, I already did that, so go ahead and take this because we're going to try to save time. So look, this is your molar mass. It's 133.33. You guys can use that.
Okay.
And that's for the AlCl3?
That's for AlCl3, yep. So now that you have all of that done, multiply and divide. So, all right, what does that equal?
Wait, actually convert it. Okay. Oh, I see. I skipped a step.
Jordan, how did you skip a step? You said everything that you needed to do. Like you were verbally telling me all 3 of these steps.
So
I think I just got thrown off or something. I'm sorry.
It's okay, but you did say them right. You actually said them all correctly. Emily, what are you trying to say? I'm so sorry.
For some reason, I wrote the 133 for molar mass on the bottom.
Okay. Oh, this one?
Yeah.
All right, just be careful because look, when you have moles here, moles have to go on the bottom so that you turn it into grams. So you have to have the 133. The grams goes on the top here. It's reverse of this one because look, this one starts with grams.
I got 23.9
grams, so grams is on the bottom, and then moles is on the top. That's because it starts with grams. This one, you start with moles, and you're putting moles on the bottom, converting it into grams, okay? So that's why some people have trouble with it because it's backwards. It's one way here and another way here. All right, so this is our theoretical yield, right?
Yeah.
23.9. That's what that means. So here's what I'm going to do. I'm going to add to this problem, and I'm going to make you give me a percent yield, okay? So let's pretend that there was one more sentence in this problem that said, in an experiment, in an experiment, 45.3 grams of AlCl3 was obtained. So that's going to ask you to now give me the percent yield.
That's the actual. This was the theoretical. So you would divide that by the theoretical.
That's it. And then multiply by 100. So take that 45.3 and divide it by 23.9 times 100 and see what you get. Oh, I should have given you a smaller number probably. I'm sorry. That was my bad. Hang on. Can I fix this?
It'd be 189%.
It would be. It would be. That's because I made it up. I'm sorry. Let me give you a different actual, hang on. Let's just pretend that instead of saying 45.3, let's say that I had said 13.4. There you go. Now that one will be better. I'm sorry, guys.
It's good.
All right, so 13.4 is my actual.
I have 55.99, or rather.
It's going to give you a crazy number if I do the other number, so please just use the 13.4.
56.07%.
That's it. And look, because I always want 2 decimals with a percent, just 56.07% is right. How do you guys feel?
On that,
A
great.
lot easier, right?
Yes.
This type of problem is much easier than the other type of problem.
Oh, very.
Okay, now look, you still need to practice, and I need to go, so let me give you some practice problems. Here we go. To practice your percent yield, I'd like you to practice number 29 on this page, page 387.
29.
Number 29.
And I'd like you to practice number 30. You just have to write a balanced chemical equation first, but you should be able to do that. And then I'd like you to practice page 394, numbers 81 and 82, which are going to have you practice the longer problems, the ones where we do limiting and excess reactant. That's what those are going to practice, okay?
Okay, you said 90 something? Okay.
Here, I'll type it in. Hang on.
Do
Page.
we have any videos to watch?
Nope, you've already watched all the videos for this chapter. So
I'm
that's
going to rewatch them.
29 and 30. So that's the first part. And then page 394, numbers 81 and 82. All right, so here we go. These four problems, number 81 and 82 from page 394, and then page 387, number 29 and 30. That's it. Once you do those four problems, that's it for that practice. Guys, Thursday is going to be a practice day, so we're just going to come in and practice problems. We'll probably do a lot more of the limiting and excess reactant because that's the hardest ones of these, but we also, I'm seeing, are still a little rusty on our stoichiometry, so you guys have to get these steps down. You got to get really good at this, okay?
Mm-hmm.
All
I
right.
think I might just be getting frustrated. There's so many different things, and even though they're all very similar.
But they all do the same thing. Listen, stoichiometry is really only one of four options or three options. You're going to convert grams to moles or moles to grams, which is the same thing, only backwards, or you're going to convert your moles to moles of something else. So that's really all that this in. For stoichiometry, you're going to have one-step, two-step, or three-step problems. That's it. Percent yield, what we just did, you do stoichiometry, and then you divide. That's it. I mean, it's really not that hard, and you multiply by 100, right?
Right.
And then the one that we just learned, all you have to do is something we've already done before, which is find a mole ratio, right? So you convert grams to moles, which is stoichiometry, so it's the same thing, and then you divide. The only new thing there is comparing it on the truth table. And then for C and D, you do stoichiometry again. So it's literally, it's not like you're even using new stuff, you're just having to remember how to do them all. You got to follow the steps, and that's it, okay? And there's really not even that many steps for that one. So just get practicing on knowing those steps. And Emily, you got to go back through that video and write them down for me, okay? Or through this video and write them down, okay? Because they'll help you, I think. But other than that, it's really just a lot of doing the same thing over and over in different ways. That's all. All right, guys. I hope that today was not as frustrating for you as it was for me. It sort of was a frustrating time because I was dealing with a lot of over here. It's hard to teach when you got like little ones running around. I'm sorry.
Good job, though.
You did great.
All right, I'll see you later. See you on Thursday.
Bye.
Yeah.